Assalamu alaikum. Now today I am going to explain the theorem 2 from chapter 9. Basically the chapter 9 is all about triangles. Okay, all about triangles, it means you need to know about the median, that the midpoint of the baseline, and other things like exterior angles, which one is actually presenting the outside of any triangle. If you extend the BC line, that one will be considered as exterior angles, and these inside angles are called interior angles. Okay, these things are, you need to know about them. And also you need to know that the sum of three angles of a triangle considered as 180 degree, and the quadrilateral, which one already you learned them in class 5, those are 360 degrees. The first theorem which in chapter 9 is the first one, theorem 1. The sum of the three angles of a triangle is equal to two right angles. This is what we are going to prove. We need to check out that if any triangle all the triangles are having three angles, so all the interior angles sum, if we make them, add them on the time, we need to prove that angle A, angle B, angle C considered as 180 degree. That one we are going to prove. Okay, the particular enunciation tells us that let angle ABC, a triangle which have three angles ABC and BACB and also BAC, and all of them, if we add them, then that one will be equal to two right angles or 180 degree. Okay, the construction part is said that we need to extend BC, that BC we need to extend on that way, like this, up to D point. Okay, and draw parallel line of AB, that will be parallel. If you want to draw a parallel line on the time, what we do basically, we just that one is pretty big for me. You can have plastic scale with you, and or adding two scale, you can just draw it like this. See, just hold it like this and draw a line. Or if you need any help for drawing that one, please let me know. I'm going to show you how to draw that one. Okay, so this is the parallel line CE. It is parallel to AB. Okay, now this construction part is already done, and we are going to go back for the proof. Okay, I decided to show you the drawing part also. So this one is 3 centimeter. No, this one is actually 2.5 inch long base. So I'm going to exactly draw the same base over here. That means 2.5 from here to there. Okay, this is both of them are equal, and I'm going to draw a side of 2 inch over here. Basically we draw geometry with centimeter measurement, but and now I have drawn 2 inch over here. As it is a theorem, don't worry, we need to get a parallel line. Okay, the line is tricky. You need two figures like this. So basically a trick thing I always try to do is, trying to be parallel with that side, that line and that line. Okay, I have adjust my 3 over here, the scale batch 3 over here, because I need 2 inch over here also. The triangle should be similar, look like similar, and this one I try to do as much as possible parallel as much as possible. Okay, you can see the lines almost here, and now this one I'm going to draw. Okay, so I already got my 2.5 inch over here, 2 inch over here. It will take a little bit time. Please do not mind giving time to your geometry sometime. Okay, oops, that one is a mess. You can see I have the similar triangles. I should write a little bit over that side, but it's okay, fine, no problem. And this one I'm going to extend. Okay, you can see I have extended the lines. So this one is my A, B, C, the first figure A, B, C, and that one is also A, B, C, the second figure. Okay, and this line is extended up to D. Okay, now another time I need to draw another parallel line on the point at point C, but you can see that I don't have the exact one, but I'll try to do my scale, both of the scale at the same time parallel over here. So you can see I have already done that one like this. Okay, this how you are going to draw two figures. Okay, this is how you are going to draw two figures, and they will be almost, I hope that, almost looking like, you know, parallel. These lines looks like parallel, I hope so. Okay, the next thing what we are going to do, we are going to prove that. So you can see that that one is the first figure and that one is the second figure. We actually transform the first figure into second figure, but we need both of the figure. Never forget that, we need both of the figure. Now we are going to talk about this figure. Okay, this figure we are going to talk about. You can see angle BAC, this one, equal to angle ACE, that one. Why? Because both of them are actually parallel. We try to do them parallel as parallel, so they are parallel. And if you think that one is the transversals on the time, definitely they are alternate angles. Okay, the second thing, the second one is angle ABC is equal to angle ECD, this angle and that angle. Okay, I'm going to mark them as X. This one will be also marking as X, that one will be Y, and that one will be Y. Why? Why? Because that will help you to remember. I never ever appreciate to remember or memorize any kind of geometry. No, never. Try to do one thing. Try to remember step like this, alternate angles. First one we will go for alternate angles. So this one and that one will be equal as alternate angles. The second step will be corresponding angles, like this one and that one. Okay, so now what we are going to do, we are going to actually placing our A angle and B angle on that straight line, and C angle is already over here. Okay, C angle is already over here, which one will be considered as Z if you think like that. Okay, so we are placing our A angle on that side and B angle on that side and we are adding them. Let's add all of the angles, like angle A, first one, BAC plus ABC and plus ACB. That means angle A, angle B, angle C. We are adding them. Now what we are going to do, and then we are going to replace this A angle with this angle AEC, and then we are going to replace our this angle with that B angle with ECB. Then we can see that whole one is actually one right angle. How to do that one? I am going to make this one as a short one and I am going to give you a picture of that. Okay, as you see that I have made a little bit few changes. I hope that you remember class 6 very well, otherwise that one you need to go and check the book. So you can see that I have changed the A angle with that angle ACE, and also the A angle actually not change. I'm going to change over here. That angle actually equal to that angle, and B angle is equal to that one angle as a alternate angles. Okay, now what we are going to do, we are going to add all the angles of triangle ABC. So adding A angle, B angle and C angle. I'm telling ABC, but you know that this angle A angle called as BAC, B angle is actually called as ABC, and C angle is A, C, B. In short, I am going to go for A, B, C. Okay. After adding them, I am going to replace that A angle with that angle. Already replaced over here, you can see that from here. And the B angle I am going to replace with this angle, alternate angle. And the C will be remain in its place. Now you can see, as I have already replaced them and all of them are in a straight line, making a supplementary angle. On the time, we can say that whole angle, adding this and that, we are getting 180 degree. So we can say that 180 degree actually two right angles, and goes over here. All the angles, if we add, the sum actually is 2 right angle. So this one is also proved. It's little bit different from your book. If you want to go with the book, I have no problem. But this one is also okay, no problem. And this is it. This is the theorem 1 from chapter 9. Don't forget that.